Yeah, they give the kids have that day off.
I
Yeah.
didn't tell you, I can't remember.
The day before Thanksgiving, yeah, the day before.
Yeah, but not college. Well, big colleges do. Big universities are closed.
Yeah, but not us.
They close the whole week because they know kids travel from all over the world. And all over the country. That's one holiday that's celebrated now being nationality. If you're here.
God bless
So
you.
notice this.
Wait a
So
minute,
notice
didn't
how
I
this
say we're
whole...
getting attention on this?
Yeah, but go down to the middle part. We start with the brain. It's about the middle of that. You'll find it. You're close. Almost there.
What do you say, 36?
One more. Yeah. Start from that point forward. Okay. So, there you are, right there.
Thank you so much. Guess what?
What?
I won.
We're on the brain.
I
What?
know. I won a trip, a 4-day, 3-night trip.
Where, South Province?
Where to South Province? Yeah. No, the Bahamas.
Oh, nice.
I know.
So it's your honeymoon now?
Even
She doesn't spend more than 2 days in Providence.
No, I don't. I try not to spend even one. I'm a big two.
I like this, how the room's slowly moving this way, because you realize I don't talk to that side of the room. I slowly drifts
Our
over.
class really died down, huh?
I don't do a shit.
All right, so now, notice it's that blue. What germ layer created this neural tube? Who remembers that?
Endo,
Ecto, meso, or endo? Which one?
endoderm.
It says endo. Endoderm created that, remember? So there it is. So it starts as this, then it starts to shape itself by week 4 into the different areas of the brain, the forebrain, midbrain, and the hindbrain, and then it goes on. And the only one that keeps its name all the way through is the diencephalon. It never changes its name. So you can see the telencephalon. So the forebrain is these two. This is the mid, and then the hindbrain. So the diencephalon will continue on to become the thalamus, hypo, and epithalamus. Telencephalon is the hemispheres. Mesencephalon, the brainstem of the midbrain with the cerebral, and those where the ventricles are. And then the metencephalon becomes brainstem, pons, and cerebellum, and the myelencephalon is the brainstem, medulla, and then you find the spinal cord. So it's just showing you how it changes itself in that short time frame into this complex structure. Okay, so there's week 5, and then by the adult, even when it's born, it looks like it's going to be in the adult. It just gets bigger in size. In some all right, so there it is. So there's at birth. So this is kind of what it would be like in you. We get the hemispheres, the diencephalon, cerebellum, and the brainstem, which is made up of 3 parts: midbrain, pons, medulla, and then the spinal cord. So we spend time in here because that's going to work most of all your body functions. So the autonomic system really relates to the brainstem. You're going to see when we finally work our way into it. So this week we'll get through this in the spinal cord, and next week we'll do cranial nerves and spinal nerves, and then the following week will be autonomic, and we're done. And that's it. Course is over. So your last test pretty much is all the nervous system. So it should make you nervous. Okay. So we'll get to that stuff. So let's go. So it's just showing you to get to see the insula. We kind of have to move frontal and parietal and temporal lobe to see the insula, because we're going to learn when we get into the main part of your brain, the hemispheres. There's 5 lobes to it. The lobes are all named by the bones. Everything gets named by the skeletal system. That's the foundation. Frontal, parietal, occipital, temporal. Then you have insula, which is deep inside. Okay, so we're going to work our way into that. Why do we show you this? Well, to show you the importance of the bloodstream running in from the brain. So here's your spinal cord. So here we are coming up. As the vertebral arteries, they unite, become the basilar, then they form the posterior cerebri and the posterior arch of what is going to be known when you get the vascular circle of Willis. We're chasing a turkey down the street.
The stairs.
Stairs for Thanksgiving. That's right. There's your cardio. So you see the internal carotid comes in, is going to form the middle anterior cerebellum, which takes care of the front, mid, and front brain. So the brainstem and the posterior part of the brain is taken care of by the vertebral arteries. So any damage to them is going to cause significance. Now, most strokes will take place in and around this thing called the circle of Willis. Circle of Willis. This is a big, important structure to keep in your mind who are going into nursing. Because when you get to med-surg 2 and 3, they get big into strokes and the cranial nerves. And they're not going to go over it with you. They're going to take for granted you know this. So they would tell you the anterior arch of the circle of Willis stroke, what nerves would be involved. So this picture, not from your books, took it off the web to show you the cranial nerves in relationship to the arteries that are running up around it. Now most strokes usually are thrombotic, not hemorrhagic. Hemorrhagic stroke is usually dead. It's a lower survival rate. Most are thrombo. And streptokinase is injected, usually breaks it down. There it is in relation to the whole brain when you look at it. Okay, so what you do is just keep these pictures with your cranial nerves. So when you do your cranial nerves, save them. Save them. I'll give you a handout how to write them out on. And this handout I'll give you that you write out your cranial, your spinal nerves, and your autonomic system. You're designing your study guide while you're doing your notes at the same time. So it works really well. Okay, so it'll be good. So you'll see it's worth having it. All right, so I'll bring those in next time. So it'll make it, it's in a concise area for you to study it and keep it. So you have it. So one thing I would say when I would start doing before we would get to them is, so look at this when you get this one. So you can see, we're going to talk about the ventricles a little bit, and we'll go back to them when we get to the spinal cord. Because most of your cerebrospinal fluid, the way you get to it is through the spinal cord, when they have to test it. So we have the lateral ventricles, the third and fourth ventricle, and we said the cerebral aqueduct connects the third and fourth ventricle. Because if there's an issue with it, you'll see a picture that would happen if you get an issue with it. Okay? And in the ventricles is where the cerebrospinal fluid is. It's made there in the ventricles. So the brain is where you're manufacturing your cerebrospinal fluid. We talked about those endomal cells, remember? At the blood-brain barrier, that's where the CSF was being produced. The endomal cells. Remember that we were doing? Yes. The glial cells? Yes. We vaguely remember that, but yes. We could go over this. I know what the Menzies said, and you know.
Quick.
You see that new study they've done, it was last week, it was done with the University of West Virginia Medical School, the neurophys department, and the University of Israel at Tel Aviv. Together they've been working on this to treat Alzheimer's. And by using ultrasound, they designed this helmet that would go over the head and blast ultrasound into this brain. It weakens the blood-brain barrier where the drugs can penetrate it, and they run in and reversing a lot of the Alzheimer type symptoms. Because the drug is getting in it, destroying the protein that creates the plaques. So the study being done in Colombia now, down in Colombia, they isolated the gene of Alzheimer's because there's one particular family, they all have it, and they found this gene. So what they're feeling now, if we can, they feel the problem with the disease is not that we can't control it, we treat it too late. So if they genetically test you because someone in your family, now usually after the age of 65, it's usually not related to Alzheimer's, it's related to something else that's greater than dementia. Well, usually it's pre-65. Somebody 51, 53, and they die very readily. Within a 2-3 year time frame, they're dead from diagnosis to death. And in this family here, everybody usually that has it dies before the age of 42. So it's brutal. And they start with symptoms like in their mid-30s. It starts, the forgetting. So it's getting pretty, so they also do, so it's 5 big pharmaceutical companies, Yale Medical School and Harvard Medical School involved in this study of if this really works, they will totally control the disease. So what they're doing, they're using the meds that control the plaquing. And if we can control the plaquing, that it doesn't happen, does it prevent the disease? That's what they're studying. Is it really the plaque creating it, or is it something else? So that's the key. So if they genetically test you, like at 18, they see you have the gene, you're going to go on these meds, and you stay on them the rest of your life. Just like a diabetic stays on insulin, people with thyroid issues go on Synthroid, and all this other crap. Even though 90% of the hormone T3, T4 is produced in the soft tissues of the body, not the thyroid. So there's other ways to stimulate that production. Not using Synthroid. You know, so you can't treat it without using heavy hormone. But enough. It's good enough. It's a big picture. But you notice how deep it runs, these ventricles. So here it's showing you a schematic. We're going to go back to this when we get to the spinal cord. But it's showing you at the choroid plexus is where this is created. So the choroid plexus is a network of blood vessels. And those blood vessels are producing the cerebrospinal fluid. The cerebrospinal fluid is very similar to blood plasma. It's a filter. So what's the difference between plasma versus whole blood? Is plasma red?
No.
It's like an off color because there's no blood cells.
Like sick.
You've taken all the blood cells out. So what's the difference serum versus plasma, do you know? You know, I'm not going to test you on it because that's all. What's the difference between serum versus plasma? Well, the serum, they take out the crying fat. That's not in. So plasma still has it, okay? So there you go. Hey, what was this? We looked at the brain. What's this street called in here? The what? That's right, the Abavite. Good job. So you can do lecture today. You know what that is. So I'll sit down and so we'll go into a little more detail with this. There's your blood-brain barrier producing, and notice the key ingredients when we produce cerebrospinal fluid. What's the two major products in it?
Glucose.
And sneezing, yes.
Yeah.
Glucose and sneezing, no, glucose and oxygen. So, what's glucose? Is it not a carbohydrate? Uh-huh. So should you go on carb-free diets because they're better for you? And no. Because the brain burns glucose, it doesn't like to burn anything else but glucose to make its ATP. It doesn't want to burn fat, it's not going to burn protein, it's going to burn glucose. So this is why the diabetic goes into these FODs where they can't think right, because why? They're not burning glucose. Body's burning fat. So you do need it. It's like we said, you know, there are healthy carbs versus non-healthy carbs.
You need carbs.
You know, an apple versus a piece of cake.
Not as many carbs as you eat, but
Especially on Thursday this week. You right? The pumpkin pie, the apple. You right? And stuff. Yeah.
don't like people.
You stuff our stuff with stuff. And it feels like your intestines stuffed because you feel like from here to here, nothing moves. You wish somebody could just put a plunger on your butt and just plunge it
It's
on.
so awful, and everyone does it, and they all look at each other with the
Like,
same
why did
look
I
of-
do this?
Yeah, absolutely, absolutely.
Why did I eat like a pig? Like it's the last day of my life. Then you almost die of indigestion because you're so uncomfortable. Well, we all do it. Unless you're doing a lot of the cooking, then you don't because you get full while you cook.
Yeah, absolutely, and that's
I
why.
do all the cooking with my wife, so by the time it's time to eat, it's like, oh, the appetite's gone.
Then you eat like a cup, like later, then you'll
Yeah.
get, then you'll,
Well, I won't eat late because I can't sleep because I get reflux.
no. Like once I'm done cooking and then I do all the cleaning, everyone eats, then afterwards.
No, what happened to this baby?
Oh.
It looks like Gazoo from the
He needs
Flintstones.
stents. How big are these stents?
He's very cerebral, isn't he? He must be very intelligent. He looks like a Martian. How many?
So
Do you
awful.
remember the Flintstones?
Oh my gosh,
Remember
yeah.
Gazoo that went from a visit Fred? That's Gazoo. No. So there he is. So that's the Megamind. So why do we see it in the child and not the adult?
Because the child's smaller, right? So as an
So I
adult,
don't, why, if you had hydrocephalus, would I see it?
because of the swelling,
Well, your brain won't swell.
because normally by the time
It's
you're
very
adult.
Oh, ours was swelled, but our skull is born.
You guys are just thinking way too much. This is you all do all the time. It's very simple. Right, and that's because it has fontanelles versus sutures. So the fontanelles will expand so you can see it. But in this case, that expansion is creating less nerve damage. In the adult, it's nerve damage because the brain's getting crushed by the fluid. So the projectile vomiting, the seizures, and just passing out for no reason is probably why it's going on in the adult version. Headache is the last symptom.
I know a little girl was that has stents.
Yeah, well, it's not uncommon to put stents in because probably the aqueduct never developed properly. And you can't go put a stent in there. No, you put a stent that runs and drops it into the body cavity. The body cavity absorbs it and gets rid of it. Okay? Like without an hospital, you know, one neurosurgeon, that's all she does, is put stents. Patient never knew what the hell it is. Comes in the room like a ghost.
So that will always fix it?
It'll fix it. They're gonna keep changing if they go over, but yeah, you know, but it'll control it. He just got a big head. He's very smart.
That's
Or
a,
she.
that's just like, my daughter's big head, and I'm like,
And they are, they can basically do it with you. So there's your wonderful brain. See, it looks like a glob of clay, your brain.
I
And
really
the ironic thing is a brain weighs 2 to 3 pounds. That's an average weight of a brain. And it goes to 10 pounds, as you said. But, and the thing is, whenever you've taken a brain out of a body and you hold it in your hand, it's really freaky because that was that person.
I like it when they cut it.
That freaks me out.
The cortex,
Like in videos, like the scientists, you see
Yeah, they
them
cut it in
and
half,
it's-
yeah.
Oh,
well, what are you gonna do? You're gonna cut
it's
it
just
in
like
half.
that's like their memories.
So usually when somebody's been autopsied, one thing that's never buried with them is the brain. Because it takes like 3 weeks to get all the slides that's cut and made. Take everything out. Take out the tongue, the brain. And that's a bitch, the tongue, the side, the set, the jaw, the white or shut.
I
You pack them
really
on the
thought,
cotton.
I really think
It's
I
so weird, you look at there's no tongue, it's been cut out. They test it. Well, certain drugs will show up. It's like I was telling them when I worked Saturday at the funeral, they go, you know, so-and-so is gone. I said, yeah, I know, because they were back to Laval, go back there, the corporation was moving out, they wanted to go back out there where he's from. No, he's gone. I said, he's dead? Yeah, he's only 37. I found him dead a week ago. Wow.
Oh my gosh.
They worked Sunday, they died. Nope. They shipped his body back to Las Vegas. So.
Las Vegas will do the testing?
I'm sure they're going to autopsy just to see who was drugs. I'm going to skip all this. So here's the falx cerebri. Remember the falx cerebri we said it hooks to the Krista Galley.
Mm-hmm.
Isn't it amazing how all this stuff you don't like still keeps coming back? It never goes away. It's terrible. It just never goes away, people. So when you're treating a human body, things that you've learned always keep coming back and bite you in the butt. Unless you don't care, they hit you for malpractice and all this other crap. Then you kind of say, well, maybe I should have studied. You get what I'm saying to you? So in other words, the course is cumulative in itself the way it's designed. Maybe if you could ask me, what does the false cerebri hook to in the skull? And you list all those things. Mr. Galley, purpliform plate, make 2 other names up. And then the final answer is, I don't know. I should make that one as a correct answer for a few other questions to see if.
See if we actually select, I don't know.
Yeah.
See? Now you're
That
gonna
there's no
have, now
answer
you're gonna
to
have
it?
me on guard on the last
There's
exam
no
now.
answer to the question.
There's no, like, yeah, there's no real answer.
Right.
See,
You totally made it up. It's so wonderful.
Don't do that. I mean, don't do that.
It's like the challenge, but like on the wrong way. I hate this, it's not PowerPointing anymore. So there's head trauma, yeah.
Yeah.
You should at least go to damn football though, right? I didn't try.
She still has, from her concussion, she still has the vestibular ocular part of it. Like when he went in with the pen, her eye went over here.
Yeah,
Her eye
residuals,
moved
yeah.
out like this. I was like,
Terrible.
awful. She looked like the guy from Billy Madison.
At
He was
least they
crazy
don't
out.
let you do any activity.
She's on step 3 for wrestling. So she's able to run half an hour, weights, and then done.
I'm surprised even that.
No contact
Depends
yet.
on the neuro. Neuro won't even let you do, some of them won't even let you do that.
Yeah, she goes to Peter
Like,
Chris.
like
He's,
pro athletes won't even, they don't even let them do that.
She's a month out. So she's worked up from 15
As long as
minutes
it's
to
one
half
side,
an hour.
they just don't let you do anything, because the damage is still there. It's not gone.
And
Rain heals very slow.
He said back December 5th. She goes to Peter Chris. He's the sports and medicine concussion guy.
Yeah.
Wait and see.
Yeah, I'm sure if you up at Boston General, one of their neuros should be doing nothing still. They don't want you to read.
Oh, she
Because
gets
that's-
audiobooks. Yeah.
That's trauma to the brain.
Yeah, she's
You
not.
can't even
she
use
gets
your
audio.
electric devices. It's trauma to your brain. Your brain's working, that's trauma to it.
It's
It
still
needs to
trying to
just
cry.
rest. We'll get into that as we go into the brain. So we're going to start with the brainstem and work our way up. So the most caudal part of the brainstem is from the movie The Water Boy with Dulan Blowjob. He doesn't have one. So there you go, Adam. See it? The way he acts sometimes. It's amazing. He's like 60. He's always dating a girl like 30 in the movies that he's in. That's kind of like weird. Oh well. So the most caudal part of the brainstem contains the inferior 5 cranial nerves, 8 through 12. Is that totally correct, that statement?
Oh, I don't like
It's
to
not
do this.
anatomy.
I don't like to do this.
Well, if it isn't correct, then which cranial nerve wouldn't belong there? Is it 8? Is it 9? Is it 10? 11 or 12? You don't have that answer. I haven't talked about this yet.
I'm gonna figure it
I
out.
don't want you to reveal the cranial nerves.
Well, I'm looking at the list of them now, so I'm trying to figure it out myself.
Nobody,
No.
nobody,
Is it,
I'm just gonna take off the
Is
end.
it
that's
5,
Harry.
6,
No.
7?
No, I said 8. 8 through 12, so you're not even at 5 or 6 or
8
7.
through 12, so those are all.
Wow.
Standard
Well, 10's for Vegas. No way. Vegas has some nice.
Vegas has motor and sensory.
They don't have any to deal with what they have. That's the one.
I'm just looking at trying to figure it out.
What a stumper, isn't it? Well,
Can I
it was
say-
only like about 15, 20 years ago they figured this out. It's number 11, the spinal accessory. It comes out of the cervical spine, and we're going to go through this in detail when we do them. It loops up through foramen magnum, and then comes out through jugular canal with the other 2 nerves. In theory, that's not, we group it with the cranial nerves, but in theory, it's not. So it's got to be some type of, evolutionary shift the way it did this from the lower animal to us. But it's not part of the brainstem. But for book's sake, the last 5. Just keep it that way. But in theory, that's not a correct statement. That's the reason why I mentioned this to you. In case somebody in here is a neurotic bookworm. Well, I'm just explaining 11 really wouldn't be there. So it would be 8, 9, 10, and 12. They definitely come out of the brainstem, out of this area. The other key thing to know about it, look at the 3 major areas: cardiac center, vasomotor, and respiratory centers. So controlling your heart, controlling your respiration, those 2 things off the top coming out of this lowest part of your brain, so you can be brain dead and still be alive. And what's vasomotor mean? It's so quiet.
Heart lump.
Well, I already said hot and lung is
No.
dope, so I'm gonna be hot and lung. What's vasomotor? What do you think? What do you think of here? Vasal. I hope not a vase. Some have had me before. I remember you sitting in class and you just don't even look up. I've never had an anatomy before I can see you're not understanding this. I never had 1070. But if you had those, you should kind of understand the term vasomotor. Well, where do we find smooth muscle? Not in the intestine. Where else would we find smooth muscle? That would sound like vasal. Or vascular.
Oh.
I was just gonna say that.
Arteries. This is controlling your blood pressure.
Holy shit.
Holy shit, this is between 9 and 10. Controlling your blood pressure. There you go. So your brainstem's doing that. That's why if you fall the wrong way and hit the back of your head just right, you're gonna die. Because you shut
Even
these
more
all
so
off.
if you're on, whatchamacallit, if you hit your head.
If they what?
My client's on medicine, he's a fall risk, because if he falls, he can die, because he's on the, apixaban.
Those are swallowing, coughing. Those are reflexes coming out of your brainstem. So when you take cough syrup, it doesn't go into your lungs and soothe the cough. It goes to the dextromethorphan goes into the neuroceners in the brainstem, so this codeine shuts them off, so you stop coughing.
So if
That's-
you drink too much cough syrup and it hurts your spleen.
I don't worry about my spleen, I'm talking about my brain.
No, but you just mentioned.
That's
cough
not
syrup,
dextromethorphan,
not
it'd be the other products that are in it. Depending on what the cough syrup is.
I was always remembered thinking about not taking too much cough syrup because it affects your spleen.
It depends which one it is and if you're affecting
Like
red blood
Robitussin.
cells. No, there's different varieties of Robitussin. They all don't have
Sure, it's like
dextromethorphan.
DM,
Right.
CM,
The one you should be taking is the DM if you got a chronic cough, because it's going to stop it. That's dextromethorphan, and it'll take it about 72 hours of taking it religiously to finally build it up and work. Where, they give you the same syrup, what it is, it's tussin with codeine. You're better off taking a Tylenol 3, because it will work better. It has more codeine in it to numb these centers. And why does it help? Well, if you numb the centers, you stop coughing, you stop the inflammation. That's why it doesn't get better. It's irritating the living hell out of the area, so it doesn't stop. So they usually put you on steroids, plus that, plus antibiotic, and you finally start to come out of it. The steroids soothe everything within a couple of days. The hoarseness goes away, and you can talk again because of taking away inflammation, okay? And then, what's a hiccup? Really?
Reverse sneeze.
You like that sneeze?
Reverse sneeze.
A reverse sneeze. They don't know what it is.
It's like a,
They don't know
usually
what
you sneeze or, because don't you skip a heartbeat or something when you sneeze? Same thing when you,
No. How do you know if you skip the heartbeat?
you know, it's always a thing, like if you
EKG's not
sneeze.
gonna work if you sneeze because you move.
So that's a lifestyle?
It won't affect you.
That's a lifestyle, see, I always learned that in school.
Yeah, they tell you, no, it won't affect it. It's not affecting the electrical part of your heart. So, a hiccup. Why? It's more common in kids. Well, it is, but what causes it? They don't know. They don't know the cause.
I heard it was something
Oh, yeah, here we go.
like your breathing, your respirations aren't with something. They're
That's
not.
a yawn.
No, it's like I don't know how to explain it the way she did, but it was like
That's
your breathing
That's
isn't.
an educated guess.
Yeah,
And it's not right.
it's not.
It's
So
something,
then-
it's something going on in the brainstem is what does it. Okay? So if you can do anything to stimulate or shut the stimulation off of the vagus nerve, you stop. Scare the shit out of you. Why does that stop? Because my sympathetic system turned on, I stop it. But you can drink 10 gallons of water, but don't stop it.
My uncle told me
Oh.
drinking water upside down worked. That doesn't. He just wanted me to choke.
Yeah.
Yeah, drink it upside down
yeah, that's
versus
an
right
old-
side up. So, They're not 100% sure why you get this. It is a diaphragmatic spasm, but why is it happening? Is it gas in the stomach pushes against it and triggers it? One of the mysteries is, my grandfather had him for a month. He was in the hospital. I couldn't stop him.
I would hate that. That'd be
I
so.
remember as a kid seeing him go to the steroid. Like a 8-year-old kid, yeah. And he didn't understand English very well. He was on the Portuguese side. And he accidentally, they left, years ago they gave him mouthwash. I don't know if it was a kid who could be in the hospital like in the 60s. They put a big glass of mouthwash like this in front of him. He didn't know what it was, he drank it. He drank the whole thing. And after he drank it, he could have stopped. I think it was the alcohol in the mouthwash numbed the nervous system and it stopped. No matter how the game wouldn't stop. And we put him on the guy a little bit, but he drank the mouthwash and it stopped. They sent him home. And then they didn't come back. And they never knew why he had the hiccups. He was exhausted from it though.
Yeah, I mean,
Even in his sleep, you know.
that's awful.
It is awful. I mean, we laugh about it. He's dead now. It is awful. It is. It brought your freaking mind. Even sneezing is a reflex. So these are all reflexes coming out of your face.
Alright, I just want to ask you about sneezing. So why is it that in the summer when you go outside to like the parking lot and you're suddenly hit by all the light, you like start sneezing?
It's not the light. It's something that's stimulated into the nasal pharyngeal level. The reflex is there. I can make you sneeze
So they
by
tell
pulling
you
hair on
to
your
get
nose.
this
That's
way.
5 and 7. So I pluck your hair out of your nose, I can make you sneeze. That's the stimulatory reflex. All right, let's go to the second region of the brain. Now, remember, this next region can also control what's in that region, but it does more. So it contains cranial nerves 5 through 7. Trigeminal, abducens, and facial, which control it. So in other words, facial expression, slap a face, hurts, and nose. Okay, abducens, you be able to move the eye out to the side. So this is the brain doing that. Stimulates. So here's why you can see eventually when your brain dead, the brainstem can't do it all by itself because it does need this. And what we're stimulating there is homeostasis. The brainstem can't totally maintain the pH balances and all that stuff that we need to do on its own. So you do need the hemisphere in the picture. But here's the other key thing: regulates skeletal and visceral muscle activity, especially flexor muscles. This is why as you're dying, and you watch people die in hospice, they always curl into the fetal position as they die. Because those muscles still will function. The extensor muscles lose their function. These stay functional. And they slowly curl into a ball. Now, if you get hit by a car, no, you're on time. Dead. Just die of a heart attack, that's not going to happen. But when you watch somebody die slowly, no matter what the type of disease they're dying from, they all look the same. They all go into that, come out like a fetus, go back as a fetus. They're trying to get back in. It's like, we're all fit. Curl into a ball. You gotta make a joke out of it, because if not, life is terrible.
It just dawned on me because I have someone who just went from stage 4 to stage 5. She's 86, Parkinson's, and she's
And now they
getting to
stopped
that.
the accident.
Now I can't get her to bend at the waist
Right,
when she's
right.
in bed. I know she's starting to slowly crawl up.
Yeah, she's still gonna curl up and say goodbye.
That's
But
it.
for her sake, hopefully it's sooner than later.
Mhm.
And the visceral activity will still be there, because cranial nerves control the viscera. So there's the pons. So the key thing in the pons, cranial nerves 5 through 7, and it's regulating the skeletal activities. That's the key thing to know. Okay? Then we get to the highest part, the midbrain. The most cranial portion of the brainstem. Yay! Contains cranial nerves 3 and 4. Oculomotor and trochlear. So again, all the eye. Ooh, the eye. Right? And it contains the cerebral aqueduct, which connects the 3rd and 4th ventricles. Give you an idea where you are. So kind of right behind it also would be the cerebellum. Okay? So it contains, this is a key thing, it contains corticospinal, you shit about this, the corticospinal tract. Contains the corticospinal. This is the white major myelinated tract for sensory and motor in our body. spinal tract, comes right out of the cortex. And it's there because it's going to kick fibers behind it into the cerebellum and without body function. So it's going to have the third and fourth cranial nerves, plus it's going to contain the spinal tract is there. We finally see it. And of course, it'll travel through the others and go all the way out. But this is the first time you're kind of seeing this tract. Ooh, there it is. Ooh. Now, let's get to the cerebellum. We have the peduncles, which are like 4 little bumps on it that would connect it to the brainstem. But the key thing is this. It has this thing called the alba vitae, which are all, again, white fiber. Looks like a tree, right? The tree of life. Smooths out body movements. Because without that, the person's going to have intention tremors all over the place. Or someone with a mild case of cerebral palsy. Not on a severe, a mild case. That they can function in society, but they tremor to no end. When they move. Not at rest, when they move. They go to pick up that pencil and they're like,
I've seen that. Yeah.
like you when you're drunk.
Going for the next shot.
But you know what I'm saying? So they've damaged this. And this happens during birth. It's not a genetic disease. It was a preventable disease. So that's what they figured out.
Is it preventable?
Yeah. The gynecologist screwed up with the delivery. That's why that happened. Big lawsuits there with it. Gynecologists can be sued all the way up to the age the person's only 23 or 24. So you're not out of the woods. Nobody wants to, the obstetrician, so nobody wants to do it. So their malpractice rates are ridiculous. You're talking 6 figures for malpractice insurance. Yeah, they make big money, but they're paying big money too at the same time. Every 5 years, you have to retake their boards and pass them, or you lose your board certifications. You know, so it's all bullshit. But there it is, the cerebellum. And I told you, I had a student that didn't have one. She was a soccer player, never knew. But they did an MRI on her when she was 15, because she cried with a girl on a CT scan. And they said, well, you have no cerebellum. But she was totally normal. The parts were there, but there was no storage facility. It just rested up against the brain. Isn't that weird? But she was totally normal.
And she was totally,
Right? I was like, wow, just throwing it out. Saying, now we get to your friend, the diencephalon. Your friend and mine, the diencephalon. Never changes name. That contains the thalamus, hypothalamus, and epithalamus. The thalamus makes up 80% of it. It's a giant relay station. In other words, nothing goes in and out of the hemispheres without passing through the thalamus. That's your major, homeostatic center of your body, is the thalamus. Temperature regulation, pH regulation, this guy's controlling it. That's why eventually you die when it's got no relay to relay to. So eventually the body can't keep the pH the way it should, and these balances go off when it's at the present volume. Passes off. These are going to renal failure, and then cardiac failure, and then they go nasty. And that's life. Hypothalamus, visual control center of the pituitary. Yes, because cranial nerve 2 would travel through there as it goes to the cortex. The only nerve that goes straight into your cortex is the sense of smell. In fact, nerves 2 and below kind of use something else before they get 3 and down, or use the brainstem, but 2, the visual optic tracts run right through fibers right into the hypothalamus. And the other one is pituitary gland. So what's the big deal with the pituitary gland? It has 2 lobes to it. Kind of looks like testicles in the skull of the brain.
testicles of the brain.
Of the brain. You'll see that when I show you.
Yep.
When I show you the nervous system. Well, it looks like that just hanging there from And what does it sit in? What bony landmarks? Solid tertiary. Right, that could be asked, could it not? Yes. See if you remember. What's the brain anchored to in the skull? That could be asked. The crystal galley, right? You should know that. It's because you learned it before, you just you forget it. So, what's the pituitary do? Nothing. We get mumps and affects that.
No, I think the pituitary is
What's the
reflective of-
pituitary do? Why if I have an adenoma in my pituitary, I'd have a thyroid issue?
Yeah, doesn't it control hormones? Pituitary.
Yes, it controls the major control of all your hormones in the body. It's the pituitary, the master gland. Controls several other functions. So it's kind of important, isn't it? And the other thing which you don't even think about, because like, who gives a shit, it's sitting there, but it's where the body, electrical and chemical activity talk to one another. Those hormones are all chemicals, and the brain's all electrical, and they communicate to regulate the whole body. Isn't that pretty neat? Well, nobody really cares. As is the green scrub, so I don't really know. That's the reason why I don't green scrub. Mean a nice neurosurgeon? Phew, I can retire after 2 years of work. No. No prenup, it's not a prenup. Okay. And then we have the epithalamus, which has the pineal body. So the epithalamus would look like a little tongue sticking up off the thalamus towards the hemispheres. And it secretes melatonin. Now that's what? Pigment, right? Melatonin?
No.
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 No?
Maybe. I don't know. Don't ask me.
No?
Mine is
Oh, you're
all
tricking
that.
me. It isn't no.
It's
What?
not.
I said you're tricking me.
Chicken?
Melatonin
Who
is
says
sleep, like,
Sleep.
yeah.
Right.
And
So you guys just
you
have a
have
lot
to
of
take out,
melatonin.
you have to take out a bunch of those letters.
You guys go to sleep while I'm talking to you, so your melatonin's
That's
working good.
skin melanin.
So why does turkey make you sleep?
Because it's got that new chemical in it.
What?
I don't know.
It's a protein called tryptophan.
Yeah,
And
that's it.
tryptophan stimulates melatonin production, and that's the reason why it makes you sleepy. And years ago, it was also when you could buy tryptophan in tablet form and give it to patients. It was a great muscle relaxer without being habit form.
So why did they go
Because
away with
some people were allergic to the tryptophan, it could kill them this way.
This
Yes.
might be a really stupid question, but
No, not in this class, go ahead.
so if they give you prescribed melatonin, is that because you lack it?
Yes, you're not producing it.
You're not producing it. Okay. Makes sense.
That's why your sleep cycle's all messed up. So that's your sleep cycle, people. Even if we put you in a dark closet, your body would know what time of day it is. If it's night or day, it's time to go to the bathroom, now it knows. Your cycle. Every morning you get up, every morning 5 o'clock for a million years. Well, guess what? Every morning you still wake up at 5 o'clock on your day off. And you say, damn it, I want to sleep, I'm tired, and you can't sleep. Because your body functions turn on. It's not dreaming about going to the bathroom, you better get up, because you're going to go back. Now you're going to have a surprising day. It depends that you work. No. There you go. That's why, because the body has this innate ability. And some people, because of stress, can lose the production, just like serotonin. You never sleep in. Try melatonin. See if it helps. You have a question, or you're just scratching your arm? When you're going like this, it's hard to tell if you guys have questions or not, because you stretch like this. You know, it's like,
So, when someone's stressed out though, and they're taking melatonin, do you think that it'll leave it and work on them because they're still not fixing the problem?
if serotonin's out of balance, probably not. It's not strong enough. But that's one, well, it has nothing to do with the bottle of wine you drank while you're eating the turkey, while you're sleeping too. It has nothing to do with it at all. You know, you mix them all together, and you're just like, ah. You just sit there and wish you could throw up. I was sorry to take a plunge and put on your butt and pull real hard and everything would just come out in one shot. It's like, damn, how much fits in there? Well, like I said, you're the one that helps cook it, and you know, the appetite's not the same. Because you lose it while you cook.
Because you're smelling and you're tasting.
Yeah, you taste it, so by the time it comes time to eat, it's like, yeah.
Mhm.
And then usually I'm drinking while you're cooking, so it makes it
Got it. Yeah, it makes cooking.
makes cooking more fun.
Mhm.
So now we get to the hemispheres. Yay! This is you! Because you're a hemisphere. Or you're a Mario's hemisphere. She's so serene, yes. So fishes would be deep pools, which would separate your waters. And then only line with that false and weedy stuff. Then you have Sulci and Gyri, remember that? The Sulci was like the valley and the Gyri was the mountain. And then we got the 5 lobes, frontal, parietal, occipital, temporal, insula. So what do you think the insula was? Insultu, that's right. Yeah. It's right. Gustatory. What's gustatory? Gustation. Years ago, that was Miller Lite's commercial when it first came out. The gusto of light beers.
Never heard that.
Too young.
I'm not, I'm old, no. I'm not that young.
Never heard that gusto of beers?
I don't know.
That was like a 70s commercial.
That's before.
That's what I'm saying, you're not that old.
No,
And even then, if you were a baby, you wouldn't remember it anyways. If you were born in the 70s, you don't remember it. If you were like a teenager in the 70s, you would remember. When you'd be sneaking, buying beer, drinking again, drunk, you would remember. Gustation means taste. Those are your taste centers. What cranial nerves are involved with taste? Who remembers what anatomy before? You read anatomy before, didn't you? No? None of you guys? Yeah, no?
12.
No.
Muscles, no, that's more.
That's muscles. That's muscles.
Fins.
So
Would it be
when
the
you-
tri,
When you study on your own?
would it be the tri?
No, that's pain. 7 and 9.
Are you shitting me? 7 and 9?
are involved with taste. 7 is anterior 2/3, 9 is posterior third. Taste, that's its sensory function. But taste, that's where your taste buds are. So you divide on your tongue. So nerve damage to that could affect taste. So there you go. Another, you know, give you a stroke with that one. Let's go on. Right direction. Okay, so now we break the brain into 3 functions: motor, sensory, and integration. Kind of like sounds like neurons, doesn't it? Since the brain is all into neurons. Motor controls the voluntary movement. Sensory, conscious awareness. So when I give you a drug that takes this out of you, you're pretty happy because you don't know what's going on anymore. So when they do conscious sedation, that's what they do. That is the best. You go out and you don't remember nothing. You wake up in another room like you're totally violated because you're up your butt with a thing, but you don't care. So I don't want to talk about probes. You were probed. Think about it when they do.
My client had that the other one, where they go in through the tip.
Oh, that's even worse.
Yeah, I felt bad.
So, conscious, you know, that's you. Then association, integration. What do I do with it? The majority of your brain is this. And some of you guys, you integrate it so well that it doesn't come back out. You see it on test. It just stays in there.
Oh, that was such a good one.
Well, I know it.
That was.
Well,
a
yeah,
good
I
one.
know you know it, but it doesn't want to come out and let us know you know it. That's the problem. You integrated it too good. It went way deep into those deep neurons that nobody's going to ever see or use. So unless you stroke out 10 times, maybe then it'll come out. So that's the key thing. So that's your area of integration, where it takes the information and stores it. What do I do with it? Is it important? Is it not? Should I react to it? There you go. to react to these other two areas that are, so the sensor you bring it in, the motor's gonna be a reaction of you checking the white box on multiple choices. Then we have white and gray, just like we did anywhere else. And so the white matter are these myelinated bundles of fibers. And the largest of them all is the corpus callosum, which we said does what? Coordinates the two, yes, the two hemispheres. That was number 13. Remember on your, looking at the brain, number 13. And then you have the association areas, meaning language. But language meaning what? Not the ability just to talk, to read, understand it, to write it. That's amazing. Not just letters, but numbers, and comprehend it. Sometimes. But that's amazing, those areas of the brain that will do this. Those are your learned responses that you're training your brain to do. Then the projection fibers, they're nothing but the major tracts that leave the cortex and come back to the cortex, such as the corticospinal tract. They're white, myelinated tracts that react very quickly. That's what they're going to connect your motor and sensory tracts. Then we have a white area. We have, a gray area. The deep, dark secrets in your brain now.
Sounded good, though.
The stuff that I don't know to know that about. That's in your gray area now. This is the basal ganglion. This controls movement as far as starting it, how intense will it be, and stopping it. And this depends heavily on a drug or neurotransmitter called dopamine. So when this is not working right, you have Parkinson's. And the generic name for Parkinson's is paralysis agitans. That's its generic name, paralysis agitans. Those are all board questions. We're working on the boards, writing and getting all this shit in the back of your mind until you forget it. But there you go. So someone that has an issue with this wants to walk a Parkinson's person. They have trouble getting going. Then when they get going, they can't stop. They walk right into something. They get what they call that festination gait. Like a train. Train out of control. Once it gets going, it's not going to hit that wall. It's going to go through. It's not going to stop. That's Parkinson's. Okay? So that concludes our brain. So now we're going to go to the spinal cord. Then we do the same thing with this. So now we go all the way up to the beginning. Let's start at the very beginning. And tells you it is. Central nervous system, yes. So the spinal cord also has. There it is, white and gray, okay. So the spinal cord also has white and gray matter. The gray matter is deep in the middle, which looked like the butterfly or the H that was in that when I showed you the model. I'm going to show you a picture that looks just like that model. Everybody would say, this might be on your test, this picture. So you know what's there. Why are you going to look pictures over there? When I say, well, I would know this picture because it might be there. Get it?
Get it?
Get it. So why is it gray? Well, there's no axons. It's all neuronal cell bodies in short dendrites. They're little interneurons, segment to segment. And that makes up all that area in the center, which is known as the horn region. So look at it, that looks like an H. H is for horn. And you won't forget it. And it's broken down into a dorsal, lateral, and ventral. If it's in the back, it must be dorsal. If it's on the side, it must be lateral. If it's in the front, it's the ventral. So either you see terms like anterior, posterior, lateral, or ventral, lateral, dorsal. You never say, I need an x-ray of the front. I need an x-ray of the front and the side. No, you don't say that. You would say, I need an A and P and a lateral view of the spine. That's what you would say. Right? You get what I'm saying? So you need to know these terms. Because you're going to see them all the time. And some of you that are already working there should be seeing these all the time when you're reading reports. So that's the horn region. So if we have a gray area, we have to have a white area, and that's the white matter, which is on the outside, which is the myelinated, because it's white, so it's myelinated bundles. Now, at this point, what would be making this type of myelin? Which cell? The Schwann cell? Or the oligodendroid cell? Or the endemal cell? Which cell? The astrocyte? The macrophage? No, which one? Which one would be making the myelin here out of those selections? The Schwann? Schwann would do it in the peripheral. Which one does it in the CNS? We're still in the CNS.
Wait, the
what? The
myelin,
The second
the oleodendroid,
The
something,
oleo-
myelin formation within the CNS.
So the oligodendroid cell.
Yeah.
Yeah, not the olive oil
Thanks for
cell.
saying
Yeah.
that.
Okay, the olive oil cell. Just
Yeah.
remember that. Oligodendroid cell makes it there. And the problem is here, when it gets damaged, it doesn't do it again. Where Schwann will, these won't. That's what makes MS such a bitch. And ALS, amyotrophic lateral sclerosis, meaning the lateral tracts are being destroyed. That's what it's telling you, its disease name. Sclerosing is the destruction of them. There you go. Multiple sclerosis anywhere. It's like years ago, I just diagnosed MS, throw a bag of things in a bag of neural disease, throw a bunch of neural disease in a bag and pull them out. That's MS. Until the advent of the MRI, it took forever to diagnose it. MRI makes it quick. It sees it. And this area is known as the funiculus, the fun area. Yes. We put fun in the iculus. Yes. Right?
These things stick in my head, so
That's
I love
why I
it.
do it,
And
see?
And I
It's just
appreciate
like
it.
the word funeral. Remember, we put fun in funeral. No. Imagine that commercial. Yeah, we put the fun in funeral. Have a clown there. Okay, so that's the dorsal, the lateral, and the ventral. Again, if it's on the side. Now, diseases like polio would go in and destroy the anteriors. The ventricles. Destroys the ventral horn, the ventral funiculus. Just destroys it. That's why the person becomes paralyzed. Can't breathe on their own. So it's nasty. Nasty disease. Got it? Okay, now that we've done these pieces, then we go into the different areas. No. The roots. So we have a dorsal root and a ventral root. Now the dorsal root is sensory only. And the dorsal root has a cell body, so that would have a ganglion on it, known as the dorsal root ganglion. Because the cell body for the sensory system sits outside the spinal cord, where the cell body for the ventral sits inside, so you never would see a ganglion on the ventral root. So there's your clue when you're looking at it, which one's in the front and which one's in the back. And the dorsal root has a ganglion. So if you mess that up, shame. Then you get the rami and the nerve, they are mixed. What do you mean by mixed? They're confused. What do you mean by mixed fibers? Does that mean they're confused?
No.
It's so easy, come on. It means they have both. Right. If you're from certain areas, say both instead of both. They have both. They have both of them.
We do. That's so bad.
One, two, tree. 1, 2, tree. Instead of tree. Right? Ocean State Farms. Sandwich instead of sandwich. Did you eat? No, Jew. No. Up the hill, right?
Up the hill.
Up the hill.
The hill.
UPDA hill. Up the hill. That's what I don't talk.
It really is.
It
It's
is.
so bad.
And some of you should go to college in the Midwest, so that you'll be made fun of every day when you talk.
You get made fun of it.
I was made fun of all the time.
Made fun of.
Our language is so bad, when you gotta like talk and you're in a big meeting out there, you feel like a moron. I tell you, okay, because you're afraid to open it because you know you speak everything wrong. You know, we cut everything short. You don't say the whole word, we say some of it. Always in a rush to go nowhere. It's a Rhode Island mentality. Well, there it is. I think it's a good picture to know, don't you? Kind of looks like the model in the lab, yes. And everything we just mentioned is there. The ventral root, the dorsal root ganglion. The spinal nerve is right there. It's very short, and this would be the dorsal rami, ventral rami, and this would be the communicating rami, which we'll talk about when we see it again when we get into the nerve, this peripheral system. Remember she mentioned those in that dissecting video of the cadaver? We're getting to the end, then we have the meninges and then we're done. But,
Oh, not like that, I'm just
oh,
freezing.
you're freezing?
Yeah. So cool.
So cold. What they say, cold hands, warm hearts.
Yeah, my feet are freezing.
Our sympathetic system's turning on then, right? So what do you think of that? Pretty cool, isn't it? And then where's the horn area? In the middle. And then the funiculus is on the outside. You'd think they would make these, like, that should be gray, but they make it brown. So why do they call it the brown area instead of the gray area? Even on the stupid model, it's not gray, it's brown.
If you print it out in black and white, it's gray.
That's right,
Works.
it works. So now we're going to get into this other thing. So I would be able to label that picture. So if you get asked, well, I would go figure 13.3b and make that my friend. If you know it, you know it for the practical, you know it for the last test. Something, I should know that, shouldn't I? Yes, I should. I changed without even doing anything. Now we're going to get to what we call the meninges. So those are the coatings that are around all that. You can see it here in this picture. See? Peels, arachnoid nerve. But what's the matter, Carl? So the meninges. So when you get meningitis, they're inflamed. Oh. So we have a pia, arachnoid, and the pia is the most inner layer, and pia means gentle. Matter means mother. In Latin, gentle mother. Right? Gentle mother. That is stuck like glue on the central nervous system. Spinal cord and brain goes through every crevice, groove, hill. It's there. You're not taking it off, and it's highly vascularized. There's a big blood supply right on the other side of it. The next layer is known as the arachnoid matter. Spider-like layer. Looks like spider. Webbed. Arachnid. And the outside layer is thick and dense, known as thick, tough mother. The dura mater, and my Spanish crowd, cabeza dura, meaning thick head. Right? How many times you said that to your boyfriend's husband? Cabeza dura. Buen punto. And then you have, in Italian, a cavarosto, thick head. So there you go. I'm sure your father said that to you a number of times. You grew up in an Italian household, you've heard that a lot. My father's head is so thick you couldn't even penetrate it with a hammer. But there you go. Now notice we have spaces. So under the pia there is no space. It's like gluing this laminate down on the table. There's no space. There's no way you're getting the pia matter off without damaging nerve tissue. That's right. So then you have a space under the arachnoid. So since it's under, we call it subarachnoid space. That makes sense, does it not? Yes, it does, Professor. Good. In 2 weeks it won't, but right now it does. Okay. In there we find cerebrospinal fluid. That's where it is. So when they do a spinal tap, they tap into that layer. So they go to pretty damn deep, don't they? And you say, ow. There's a space under the dura called subdural. In theory, nothing should be there. That's an expansion space. So if you have a little excess fluid, it can push and there's no issue. So the body reabsorbs it out. But in cases of trauma, that's where the blood would get trapped. So that's why you always hear the term subdural hematoma. Because it won't rupture through the dura. It's too thick and strong. That epidural space, just keep it in your mind, and when you look at the pictures and go on it, we're gonna show you how that forms. It says below L2, so just keep that in the back of your mind. Now look at this picture, isn't that pretty? So what vertebral level am I at? What vertebrae is that? Cervical, thoracic, or lumbar? Come on, let's go. Which one? How do you know? Because of what holes? These? What's the name of that?
Transverse
Transferring.
Yeah.
Vertebral arteries, yes, good. See how it's still gonna come back? You gotta know it. We just didn't know it for test one and forget about it. No, we need to know it. So I'm trying to make you understand. Here's your nerve roots coming out, right? So that means the vertebral foramen would be in this area. And look, there's the pia, there's the arachnoid, there's the dura. Notice how the dural sleeves go out into the nerve roots. So when you have adhesions of them, it hurts like hell. And that's what trauma does, creates adhesions on it. So you get all this pinched nerve symptoms and stuff. Nerve's not really trapped, it's just adhesions on it. And you gotta break them up and they feel better. But notice in the epidural space, there's no space, there's what?
Fat.
Fat. So there is no space. But when you go to the next picture, we'll see how we make the space. Son of God, look at that picture. Looks like the model in the labs. Yes, it does. And notice at around L1/L2, the spinal cord ends at a level called the conus medullaris. Well, when it ends at that point, it now makes space above the dura because everything's more compacted together. Because it continues on as a bundle of nerve that looks like the tail of a horse, known as the chora equina. And it can, so from this point on, L2 down to S2, we have a space above the dura known as the epidural space. And who's ever had a baby and had an epidural, raise your hand. There you go. That's what they inject into.
Oh, it's such a good thing.
And the solution stops around this level, so everything from L1 down, your belly button down, numb. You don't feel it anymore. So just yank that thing out of me because I'm done. So you had for both epidurals?
I had one natural and one, my first was an epidural. She was like 10.5 pounds.
Oh.
So I have a question.
My
Yeah.
Because I got an epidural for my son and it didn't work, and the
Oh my
doctor
God.
said it's because the physiologist did it wrong.
Because the,
How does that happen?
they went in the wrong space.
But I was
Oh, what the hell? They were above, way above everything.
It hurt when they put it in.
Yeah, because they injected right underneath and there was nothing, had nowhere to go.
I just remember them saying, make a C. I was like, I got a watermelon in my stomach.
Yeah,
They kept
well,
saying, bend
you're
like
gonna
a
bend
C.
forward to open up
But see, he didn't have me bend forward, I just laid on my side.
enough.
Oh my
Oh,
God.
no. Everybody
Somebody
was
did
bend.
you wrong, girl.
I
They
know,
wanted-
let me tell you, that hurt more than.
Yeah, because it hurts, because it goes in, but it hurts to go in there and do it. So that's an epidural. They're in the
You can
epidural
sue them
space, and
for
from
that.
everything
How old
here
is the
down.
child? You just said you can still sue.
You
Yeah,
literally
so-
could
Go.
sue them for
Call
putting it in
today.
wrong.
Cole, what is the
Oh,
guy?
wow.
Gemma, what's the guy?
No, the one on TV, what the hell's his name?
Yeah, I can't find
There are,
it.
there are plenty of them. that you
No,
can
it's the
watch
one with that
commercials.
jazzy, like they all put them jazzy
are
ass
you a
commercials.
victim?
And we're bam.
Ba-bang.
Bam.
Are you a victim of medical mal- Now, what's this thing, the phylum terminale? Why is it green? Remember that? We talked about it. Does that conduct any impulses? The answer is no. The phylum terminale is nothing but a modified pia mater, which goes from the conus all the way to the coccyx to anchor the cord. So that's your anchor. So now you know everything. Aren't you impressed with yourselves?
So excited.
So excited. A couple of things that we're done. This is another hour. So you must stop basing your Okay. There's what it looks like for real. Looks like sushi.
That is
Doesn't
freaking amazing.
sushi.
Now, every time I eat sushi, I'm like, there you go.
I think it's
Oh shit, it's sushi's
Right
half
here.
price today.
You got sushi today?
No, it's half price at that place, 10 minutes away.
Yeah, I don't care. Now
No, it's
notice
good.
here it
What's
says
the name?
CC1 to C8. Wait a minute. That's a mistake, is it not?
Say that again?
Why is there 8 cervical nerves? But there's 12 thoracic, 5 lumbar, 5 sacral, 1 coccygeal, altogether 31 pairs of spinal nerve. Why are there 8 cervical? Because they're named differently. They're named by the vertebrae below. So C2 is above C2. In the thoracolumbar spine, named by the vertebrae above, so T1 is below T1, T12 below T12, L5 below L5. That's why you end up with 8 in the cervical spine, it's already numbered. Now, cerebral spinal fluid, we know, made in the choroid plexus of the brain, in the ventricles, found in the subarachnoid space, similar to blood plasma. How does it protect the central nervous system? Well, that's nature. Well, one, it's going to bring nutrition and take waste away. 2, it cushions it. So when you have trauma, the brain doesn't whack the rest against bone, there's a cushion layer of fluid. And 3, the most important thing, it floats, the whole system floats within this cavity. Because if your brain didn't float, it would crush itself under its own weight and you would die. And there are diseases that do that, bladder-basal, basal imagination, where the bones soften of the skull and it looks like the skull is melting over the cervical spine and it crushes the brain stem. And the person dies from that. So there are nasty diseases out there that cause all these things, people. But there's the reason why we have it. And we look, say, oh yeah, choroid plexus, there it is again, in the ventricles, produces CSF, which is similar to blood plasma, and it contains 2 real important ingredients, glucose and oxygen, plus other things. There's your blood-brain barrier right there. And why is it so important to know where the spinal cord ends? Because if I do a spinal tap, I go in between L4 and 5, I cannot nick your spinal cord. And then insert the needle in the subarachnoid space. Altogether, you have about 4 ounces of cerebral spinal fluid. That's it. In the whole body. Half a cup. It's
So
not
when
a
they do
lot.
a spinal tap, how much are they actually taking?
Well, milliliters.
The whole thing.
Enough. That's not all.
I'm
I know.
saying,
Well, you replenish it pretty quick.
okay, that's what it's
You replenish it pretty quickly, okay? So where would they do it on a newborn? Because their spinal cord goes all the way down to the coccyx.
Wait a minute.
All the way L4 to coccyx, depending on the age. They call it a cisterna puncture. And it's between the occiput and C1.
A couple of minutes. Shit, I just said that.
How would you love that? I would like to be that pediatric neurosurgeon intern, and that's the first thing you're going to do today. Never done it in your life. On a sick newborn, you're going to take.
That's who's, okay.
So you get nervous about the practice. I'd be more nervous about that. Look at that. Ooh, what is that?
What is-
Myelomeningeal seal. That's the meninges outside. So that's the durability. With the spinal bifida. They pop a pin and it goes way down. You didn't hear that before, baby. This picture was in the books for like 3 decades.
I was like,
They never operated it, even the new version. All right, so now you're experts on the central nervous system, how nerves work, because you've learned the physiology. So next week we'll go into cranial nerves, spinal nerves, autonomic nerves, and the nervous system is done. So a couple more lectures and you're done.
So we don't have